Antiarggregants. Platelet activation and their subsequent aggregation occur under the action of various mediators. To inhibit platelet activation and prevent aggregation, antiplatelet or antiplatelet drugs are used, which can act on both mediators and platelet receptors that are susceptible to certain platelet activator agonists. In a lecture on the structure and function of platelets, we examined in detail the substances and mechanisms of adhesion, activation, and aggregation of platelets. In this lecture, we will consider the mechanisms of blocking platelet aggregation. Based on the platelet activation mechanism, the following targets can be identified for potential exposure to inhibit platelet aggregation. By inhibiting cyclooxygenase of the first type, it is possible to reduce the production of thromboxane A2, which is a platelet activator. It is possible to block thromboxane receptors, and thus make the platelet insensitive to the activating effects of thromboxane A2. It is possible to block the glycoprotein receptor 2b3A, and thus prevent its binding to fibrinogen, which is necessary for the binding of platelets to each other. It is possible to block adenosine diphosphate 12 receptors, preventing the activating effect of adenosine diphosphate on platelets. Besides, it is possible to block the vapor receptor, preventing the activation of thrombin on platelets. Acetylsalicylic acid inhibits platelet aggregation due to irreversible acetylation and inactivation of the first type of cyclooxygenase. As a result, the effect of acetylsalicylic acid on platelets is an irreversible permanent violation of thromboxane-dependent platelet activation, which reduces aggregation processes, as cyclooxygenase is inactivated for the entire life of the platelet from 5 to 10 days. Non-nuclear platelets cannot synthesize the enzyme cyclooxygenase de novo, which leads to persistent blocking of thromboxane A2 production. Approximately 10% of the pool of healthy platelets is renewed in the body every day, which means that in 5 days there will be about 50% of the pool of healthy unblocked platelets. Adenosine diphosphate P2Y12 receptor antagonists inhibit platelet activation by blocking the P2Y12 receptor, that makes this receptor insensitive to the activating effect of adenosine diphosphate on platelets. This group of drugs includes ticlopidine, clopidogrel, irreversible effect; prasugrel, irreversible effect; ticagrelor, reversible effect; congrelor, reversible effect. Reversibility of exposure indicates the ability of platelets to aggregate and is fully restored after the binding of the drug to receptors is lost. Fibrinogen receptor blockers. Glycoprotein antagonists 2b3A prevent the binding of this receptor to fibrinogen, which is normally necessary for the aggregation of platelets with each other. Thereby suppression of the process of aggregation of thrombocytes. The following drugs belong to this group of drugs. For intravenous administration, abciximab, eptifibatide, tirofiban. For oral administration, zimilofibin, orbofibin, cibrafibon, lotrafibon. This group of drugs is characterized by reversibility of the effect. Thrombin PAR receptor antagonists, protease-activated receptors, such as vorapaxar, prevent the activating effect of thrombin on platelets, thereby reducing platelet activation and aggregation. Using thromboxane receptor inhibitors. Platelet activation can be blocked by thromboxane A2 by rendering thromboxane receptors insensitive to thromboxane A2. These drugs are ifetroban, sulatroban. The process of aggregation can also be disrupted by endogenous compounds. An example is a prostacyclin. Prostacyclin has its receptors on the platelet surface. Prostacyclin causes activation of adenylate cyclase, which leads to the formation of cyclic adenosine monophosphate in the platelet. Cyclic adenosine monophosphate reduces the intracellular concentration of calcium, thereby preventing platelet activation. Changes in the conformation of the glycoprotein receptor 2b3A, which is necessary for the binding of fibrinogen and platelet aggregation. Cyclic adenosine monophosphate in the cell can be destroyed to an inactive of adenosine monophosphate under the action of the enzyme phosphodiesterase, thereby reducing the effect of cyclic adenosine monophosphate on calcium levels. Phosphodiesterase inhibitors, dipyridamole and trifluzel, prevent the destruction of cyclic adenosine monophosphate, thereby reducing the intracellular calcium concentration, and does not change the conformation of the glycoprotein receptor 2b3A, which is necessary for the binding of fibrinogen and platelet aggregation. This means that platelet aggregation is reduced. Adenylate cyclase stimulants, iloprost and other prostacyclin mimetics may increase platelet cyclic adenosine monophosphate levels, which helps to reduce intracellular calcium concentrations. This means that there is no further change in the conformation of the glycoprotein receptor 2b3a, which is necessary for the binding of fibrinogen and platelet aggregation with each other. And as a consequence, platelet aggregation is reduced.